This is the second part of our chi-squared worked example. In the last presentation, we were given these observed values, and let's just change my pen size there. We were given these observed values. This is a flights example, ticket types versus destination, and we were given these observed values, and here they're in the top row for each cell. Okay, and what we did in the last presentation is calculated these expected values under the null hypothesis. The null hypothesis is that there's no relationship between the ticket type purchased and the destination. And I'll let you look at that again if you're not sure. So what we're going to do now is calculate the test statistic. Okay, and the test statistic is for each cell. What we have to do is this calculation and then add them all up. Okay, so for each cell what we have to do is calculate is the observed minus expected, square that and divide by the expected value. Okay, so in the first instance, let's go down here. In the first instance, the observed value would be 65. So 65 minus 87, square that and then divide that by 87. So we're going to do it for each cell. Just go to the blank page here and we'll scroll up and down. So it is 80. My software is jamming up for a second. It'll just take a second to clear. There we go. So, oops, gone too far there. Yeah. So so cell 1. I'll actually do cell by cell, just to make it easier to follow. Okay. Okay, so we have 6 cells altogether, and what we have to do, so in the first case what we had was 65 minus 87, so we square that and divide by 87. Okay, the next cell is 55 and the expected value. So this is the top row. The observed value is 55, this one here. And then the expected value is 33. So 55 minus 33 squared all over 33. We do that for all 6. So it's 140 now, the business executive domestic flights. So that is 140 minus 174 squared over 174. The next one is, oops, gone too far there. 100 minus 66 squared all over 66. The next one is 520 minus 464. Square that and divide by 464. And finally, I keep going to the wrong one, 120 minus 176. The squaring actually gets rid of the squaring gets rid of the negatives, the not minus signs. So this is a bit of calculator work now. So I'm just actually going to just on the side here, I just have my little notes that I can use. I'm just going to have them slightly out of shot there. But essentially what's going to happen is I'm going to add all of these up, or calculate each one of these individually. Now, this actually takes quite a bit of time to do. So to 3 decimal places, that is 5.563. To 3 decimal places, this is 14.666. The 3 decimal places, I get 6.643. The 3 decimal places, I get 17.515. To 3 decimal places, 6.758. And finally, 17.818. So that is, there's quite a bit of work there. Now I've just sort of managed to fly through it in the 2 minutes, but it actually takes quite a while to do it. Now, what we do is we add up all of these together. So 5.563 plus 14.666 plus next row 6.643 plus 17.515 plus 6.758 plus 17.818. I made that, and again, allowing for a bit of, I actually have the answer calculated directly from statistical software, so there might be a little bit of rounding error issues, but you should get somewhere around 68.96, so give or take a few decimal places depending how the rounding worked out for you. So 68.965 is my answer there. So that is our test statistic, and it's quite large. The next thing we're going to do is calculate the critical value. And the first thing we have to do is actually determine degrees of freedom. So the degrees of freedom, if we actually look at how many rows and columns we have, okay? So we have row 1, row 2, row 3, and we have two columns, C1 and C2, okay? So we have 3 rows, okay? The number of rows equals 3. The number of columns is equal to 2. R minus 1 is 2, and C minus 1 is 1. So R minus 1 times C minus 1 is 2 minus 1. That gives us 2. Now, just a sort of a little clarification here. You don't include the totals. You don't include the totals for your row columns or total. So they are not part of this calculation for degrees of freedom. So it's the number of rows. The number of rows. I'll just go back here. It's too far. Yeah, the number of rows divided by the number of rows. Here it's 1, 2, 3. Number of columns 1 and 2. So that's where we get R minus 1 times C minus 1. Now, that is our degrees of freedom. Now we're going to use a significance level of 5%. Alpha equals 0.05. Okay, that's our significance level. I think we were told that in the start of the question. Let's just check that. Yeah, down at the bottom I sort of said use a 5% significance level. So that's important. Okay. So let's scroll here. So it's what we do here is we go to degrees of freedom is 2. Okay. And we go down on our here along the row where we have the significance level of 5%. The answer we are looking for here, and it's a little bit faded just because the way I've done it here, it's 5.991. Okay. Some other books might just give you 2 decimal places, so it might be 5.99 in other books or other tables. Anyway, the critical value we're looking for is 5.991. Okay, so that's an important part done there, 5.991. The test statistic is actually the main part of it, but the critical value takes a bit of work as well. So how do we interpret, make a conclusion? So if the test statistic is greater than the critical value, here we have 68.965, and we're seeing if this is greater than 5.991. Obviously it is, but now we know that. Reject the null hypothesis. So is this true? Yes. Okay, reject the null hypothesis. What is the null hypothesis again? It's from the earlier on we sort of looked at it. So the answer is reject the null hypothesis, but let's just remind ourselves what the null hypothesis was. The null hypothesis is that there is no connection between ticket type and flight type or destination type, and so you under the null hypothesis you buy a first class ticket regardless of whether you're going domestically or abroad. On the alternative hypothesis, you're probably more likely to buy one or the other depending on how far you're going. Just let's say for argument's sake domestic airlines or domestic flights are shorter than international flights. So under the null hypothesis you buy an economy no matter what. Under the alternative hypothesis, you might be more likely to buy one or the other depending on how far you're going. Anyway, so according to this data, we reject the null hypothesis. It seems to be that case that there isn't a connection between flight destination type and ticket type. So we leave that there.